Oh, it's this guy. Database management. I control it. Can we make it louder?
Now I keep data in records.
Thank you.
Tables like these ones here. I have a table for teachers' data, a table for classes, and a table of student data. Hi guys.
Hi, Mr. DBMS.
He's kind of reviewing, so.
Now, tables on their own are great. The student table contains all the data I want to know about each student. The class table tells me who is teaching and studying each class. The class is the link between the teacher and the student. And to understand this, I need some way to join the tables together. I need to understand what the relationship between the tables is and how to record who is taking what. I'll start by making sure I know who we are talking about. Hey, Mark.
Hi, Mr. DBMS.
Good, no problem. He's Mark. Hey, Joe.
Hi, Mr. DBMS.
Oh, that's a problem. With so many people in the world, I can't use everyday information like their names. To be sure, I have to give them something that I can be absolutely certain is unique, a key that will only unlock the correct person's record. It's called the primary key. Every record must have a different value for its primary key. So key number 1 here is given to Joe, and key number 2 to the other Joe. Now I won't ever mix them up again, as long as I use their key values rather than their names. Primary key. Primary means first, and it's because it's the first thing I have to look for if I want to make sure I get the right record. Now, how does that help me record what classes Joe, sorry, the one with primary key number 1, attends? If we take a closer look at the classes table, you can see we have some records here. Some of these records look like they have little Joes on them. Hey guys, what do you have there?
Hi, Mr. DBMS. We have Joe's key. I have it on this record, which is his English class. And I have it on his record, which is his French class.
What gives with the hats?
Well, we had to travel across the relationship to get here, so it's like we're on holiday. Our keys are foreign keys because they're on a different table.
Yes, that's right. On the student table, Joe's key is the primary key. It's unique and it unlocks all the information about Joe. But here on the class table, it can be used in many records, once for each class Joe attends. And what about those other keys? That's another foreign key. Can you match it up to the student table to see who it belongs to? The key is the same as Mark's, so those must have been Mark's class records. But look closely, and you'll see there's also a different key on each record. Hey guys, what are those other shaped keys doing there?
Oh, they're the teacher's keys. If you use them on the teacher table, they'll tell you who teaches the classes.
Right, so are they primary or foreign keys? Ah, trick question. They're both. It just depends on which table they're on. On the class table, they can be used many times. One teacher will teach many students in a class. So here on the class table, they are foreign keys. If we create a relationship with the teacher table and go over there, we should be able to find the matching primary key value. Now, who has the same key? Oh yes, Mr. Smith. Using keys like this to join tables, make sure we don't mix up any data. Very important. And I'm sure you wouldn't want your dance class to be mixed up with your history one, would you? Maybe you would, but not me. I like everything in the right place. One primary key for each table that must be unique for each record. And if it is used on another table, it's then called a foreign key.
He gets freaky. Okay. Just got some lag here at the end. All right. He keeps changing things. That's all right. Yeah, way early. Okay. So when we're working with joins like this, we saw that we are having to tell the database management system how these tables are related. Sometimes to students, it seems like that is unnecessary. Like the database management system should know how these tables are related. I shouldn't have to say join, orders on this order ID? Why doesn't it know? Well, it doesn't know. So that's part of our job in building the SQL statements, is to say, this is how I want you to establish that relationship.
Well, I mean, one could argue that it does know, and that happens to be exactly how it knows, though. Like,
Because you tell it. when
because
do
you tell
query.
it, this is how we're going to tell.
And he mentions a good relationship in that video. So he talks about students and teachers and why in the world can't I just make a relationship here? Many students, many teachers, right? Because I as a teacher am going to have many students. You as a student are going to have many teachers, right? So that would be a many-to-many relationship, right? We would have many. Whenever we're looking at a many-to-many relationship like this, the database management system can't support that. It's not a logical structure that we can use to build our queries with. So we always resolve that many-to-many relationship by creating a link table. And you'll see a little bit more about this as we go on. But in our link table, we're going to have our student key to cause that relationship to be created, and we're going to have our teacher.
And in this case, it just happens to be the classes that we're respectively taking and teaching.
Right, we've been able to take that link table and say, we can make this link table into meaningful data. It's a class. So we could add additional information like the class name, the class location, times, things like that. But we don't have to. But we do have to always resolve a many-to-many relationship. Now, one student can have many classes. One teacher can have many classes. So by creating that link table, we're able to resolve that. So now if I wanted to run a query and I wanted to join these tables, I could say, select these columns from the student table, join the class table on student ID equals student ID. And then that would give me a list of all of the classes for that student. Now, whenever we're resolving a query like that, do you still have that Excel spreadsheet we looked at last time? Let's open it back up. If you don't have it, remember it was on the announcements in our Canvas course. And I want you to think about kind of how, let me see if I've got it, how these things are resolved by the database management system. So looking at my Excel spreadsheet, I have our vendor information, and then remember we have our invoices information. If we ran a query that said we wanted to select the vendor name and invoice number from vendors, join on invoice where vendor ID equals vendor ID. If we ran that kind of query, the system would create an interim table. So you don't have to do this. I just want to kind of show you what this interim table would look like. I'm going to create a new tab here, and I'm going to call it interim. And let's say I wanted to get all of the invoices for vendor ID 72. So I'm going to copy that row and paste it in my interim table. So the database management system is going to do this interim table that it's building. Then it's going to look at invoices, and I want to find invoices for vendor 72. Well, here's one. So I'm going to copy that. Let me copy this data a little bit better instead of copying the whole row. And I'm going to add that to my interim table. I'm going to paste it here in my M column. Now, that gives me one interim row, right? Because now in this interim table in memory, in the database management system, I have the whole piece of information about the vendor and all the information about this first invoice. But we're not done yet, right? Because we have another invoice for this vendor. So we'll create another interim row. We've got to start with all this vendor data. So I'll copy it again. My interim is spelt wrong, and I'll paste it. And then I've got another invoice. So I'm going to gather that invoice data and paste it. So now internally in memory, the database management system has this interim table. See how it has all this duplication and stuff that we've gotten rid of? Well, it has to put all that back in, and then it can give us the results that we want. So the interim table is something that can use a lot of memory, because if the system is having to go through our entire vendor table and select all of them, and then go through the entire invoice table and match things up, it can take a lot of resources to build this interim table to pull our data. So just think about it. If you were wanting to do some sort of sorting or summarizing in Excel, you would have to build this table this way so that you had all of the information about the invoices for this vendor. Now I'm going to try to spell this right. How do you spell I can't spell today, but I'll save that and we'll just continue. So when we're looking at a join, you just want to create the connections within the database. So if I wanted to get all of the students and all of their class ID or teacher IDs that that student had, should I start my query at the class table or should I start my query at the students table? Which table would I want to have first in my from?
Probably the student table. I would probably say, because that's.
Do you guys agree with him? Why? I think that's right. The student table, if I look at the data, there's going to be fewer, right? Because for 1,000 students, I can have 4,000 of these class records. So that's one reason I would want to start here. This is also anchor information that I want is from the student. So that's why I would want to start here. Okay, so let's do some more joins. I'm looking at the presentation that I have. Let's see where we were. Where I left off last time was on slide 14, and we were looking at this self-join. This was the last thing that we did last time. And in this self-join, it got a little ugly. We said we wanted to join the vendors table to the vendors table. And we wanted to join it if their cities were equal and their states were equal, but their vendor ID was not. And this query was an example for us of listing all of the vendors that are in the same city state as another vendor. We would say it right. So lots of stuff. I got to open SQL Management Studio. I don't have it open yet. And then, of course, I got to get out my entity relationship diagram, because if I'm going to be working with the database, I want to be looking at a visual of it. I'll have a few extra copies. There's people that don't have them. Put them up here if you need one. Now, if you go into the office of somebody that works with the database a lot, you'll probably see pictures like this posted on the wall, because they just keep them around and up on their bulletin boards and stuff, so they're readily available. Now, if you guys noticed, looking at the homework, you'll be working with the customer side of our database, where our practice stuff, we usually work with the vendor side. The structures are real similar within the database, so that the practice queries that we do are very similar to the ones that you'll have to do for the homework. So hopefully they'll work out to be good practice. Now, last time we were trying to save all our queries, and they got a little ugly. So I'm going to try to take a little bit more control of SQL Management Studio here, and I'm going to do File, New Project before I start. See if I like the way this works. I'm going to say this is going to be SQL Server Scripts. This is my project name. Then I want to double check my location. Mine is set to the C drive, and I don't know if their override is taking that to my OneDrive or if it's leaving it here on the local machine. Is it taking it? I think so. I think it grabbed it. So, I mean, I think that it was able to pull it still automatically. So I'm going to leave it there. Now I want this to be then my chapter 4, and this is going to be joins session 2, since we'll call our last time as session 1. Let's see how the project works. Right here, just like Visual Studio, I have a checkbox to create a folder for that solution. Sure, I want to do that. Let's see if we like it. Now, the only difference that we see over here, we've got kind of a little solution explorer now for our project. So let's see how it goes. Whenever we were looking at OneNote last time, I was showing you these notes about iter joins, and I want to make sure everybody's got all this stuff down. This is from my OneNote, so you need to put it into your OneNote. Well, you might type it. It's up to you. I would prefer you type it so that it actually goes through your brain. So I'm going to give you guys a second or two to get this into your OneNote notes. If you haven't created a OneNote notebook for the class yet, go ahead and create it. So we have some important things on these inner joins. We worked on the inner joins last time, and we saw that in general, we're going to join 2 related tables, but we could join many, many tables, more than 2, right? We don't have to, we're not limited to 2. We normally are going to be specifying a primary key on one side of our join and a foreign key on the other side of the join. We saw that the explicit syntax uses the keyword join and the keyword on. And I have that implicit syntax kind of down below. But if you remember, the implicit was where we used the where clause instead. And I told you people had done that for many years, so you might find that in the field. But the explicit syntax is what you prefer. We saw that sometimes we might need to help the DBMS figure out what column we want by qualifying our column name with the table name. We put the table name before the column name with the dot. And then we use the as clause a little bit more. In chapter 3, we use the as clause to supply synonym names to columns. This time we used it to supply correlation or synonym names to tables. We saw that with our joins, we could have ands and ors and complex criteria. So just like any compound condition, we can do that in our joins. And if we want multiple tables, we just repeat that join and on keyword. Then at the end, we saw a self join where we join the table to itself. We would normally use the distinct keyword with that kind of join so that we don't get a lot of redundancy. And we're always going to be trying to think about that interim table that the database management system is creating. Are we giving it enough information to create that interim table correctly? I can really confuse the database management system the way I form my queries if I want to. And sometimes I don't want to, but I still do. And then we did that one query with a fully qualified object name. And remember, we looked at the properties for our server. I did really fast to find our database server name. And then we were able to use a fully qualified name that starts with database server, that database name, that database owner, that table name. And those are really ugly. And then this picture, I searched Google for an inner join Venn diagram, and I found one that I liked. And so these diagrams are really helpful when we're thinking about joins, because I can think about this then, if table 1 is my student and table 2 is my class table, this data in between is the classes for this individual student. I miss clicking keyboards. I wish we could request them. You guys are so quiet with your key. So can you see why this one's called an inner join? This one's actually called an inner join because of this relationship, the way it works out with this Venn diagram. We're getting the stuff that just joins between the two tables. Only those things. So if a student doesn't have a class, we don't want to know about them. You know, there's just not going to show up in our join at all. So we're only going to see things that are in both tables. Well, why does that matter? Well, because we have other types of joins. So what if we wanted to actually run a query and we wanted to find out what all students don't have a class? We only want those students that don't have a class at all. They have no matching class. That would be an outer join. Now, with an outer join, we have some different options here, and we'll do some examples of these. But first of all, what are they talking about here when they say left join and right join? Think about the syntax. Let me type one in here. If I say select student ID, class ID, I'm using our fake tables here, from student join classes on student ID equals class student ID. Now I want to type that in because I want you to think about that. Now looking at this statement, which table is on the left of that statement? It's weird, isn't it? I'm going to put the join clause on the same line as our from, and then it makes a little more sense. Now, which table is on the left? Student, the student table, because it is on the left of that join keyword. Does that make sense? And which table is on the right? Class. So whenever they're talking about these left joins and right joins, they really are physically located that way in the query. So here, if I'm saying that I want to do a different style join, like I only want the students that don't have classes, I would change this from just a join keyword to the left join keyword. If I only wanted classes that don't have students, something like this, where I wanted classes, all classes, would be what we would get here, then I would make it a right join. So we'll have some different examples. I'll let you look at this for a second and then we'll go do some examples. The pictures that I have are just from different sources.
What's 4A supposed to say?
Do it.
4A. What's that supposed to say?
Let's see if I can make my pointer. Each, let's say, I think we could do better by saying each row instead of each from. So each row from the first table is joined with each row from the second table. That might sound a little better. There's my tables. I need a drawing tablet or something that could be a little more effective. So oftentimes in programming, we're always thinking there's some sort of relationship or something to this code that we're not seeing because we're not privy to what the original creator had in mind or whatever. But with SQL, with the left joins and the right joins, it really is literally what location they are within our from clause. So let's do some practice ones. I'm going to see if I can get this thing set up a little better. You guys joined 4 tables yesterday, right? So, or last time. You've got that. Now,
I have a question about those.
uh-huh.
What if you keep getting ambiguous column name? Ambiguous column name.
So what is ambiguous column name? Help us out. What does it say in that if you get that kind of message? I've seen some people figure it out. What's it telling you?
It's wrong.
Not exactly. What's it saying if it says it's ambiguous?
It wants to know which table it's coming from.
It sees that column in more than one table.
Yeah.
So you need to specify which table. That's why it's ambiguous. Because it's like, I see this column, but I see it in lots of places. So which one do you want me to use? So that's where you put your table name dot before it.
Well, I did that and it's not doing that. That's why I'm confused. 'Cause I did like, from customers join orders on customers.customer ID.
Do you want to put it on the screen? I'll stop sharing. Okay, go ahead and
Yeah.
share.
That would be awesome.
Let's see if we can.
I keep looking at research too at the same time. I'll do- Sorry, I should have Zoom up at the same time. This is where I'm having my issue. I guess. Let's see if I can do which one it was. Nope. And bigger.
So in your select statement, you're not telling it which table.
I thought that's what this is.
That's where you're telling your join statement which table.
Oh,
But in your select statement, it's completely separate. So we still have to tell it which table. And so as you guys work with the as clause, assigning things synonyms, sometimes that's why people like to do that, because they have to put that table name in so many places. They like to shorten that name down a little bit just for that query. So we might end up with, does it take that now?
yeah, it does. It's just so weird because like it's repetitive.
Right, it's super repetitive, and that's the thing about SQL. It's very, very consistent. It's not going to do one thing one time and something else the next time.
At least I don't feel like an idiot because I feel probably a lot of people make that mistake.
That's good. They'll all need to know. Now, nobody else will have to. They'll know it. So if it's griping at you like that, it just can't figure out what table it wants. So looking at this query with 4 tables, we're starting at our vendor table, joining our invoices and our invoice line items and our ledger accounts. When we do that query, internally, the database is going to start out with that interim table. So the first thing it's going to do is pull what? What are we seeing here based on our query? Vendor name, invoice number, and invoice date. So we're seeing like our first 2 tables combined. But now we've got to go to each of those line item amounts for that invoice. So now our FedEx interim rows gets increased because now we have interim rows there for all of those different line items. So we can see our interim table getting a little bit bigger. And then when we add in our account description, we're getting more data, but we shouldn't be adding more rows because we're just using the general ledger account ID that we have to find that information. I'm just going to kind of keep going here because we did most of these. So we are up to page 22 is where they start with their outer joins. So let's try their first example is on page 23. And in this example, we're going to do a left join. So let me get my screen formatted here a little bit better. I'm going to go to my database. And then I'm going to move this over a little bit. I guess I can make it auto hide. That'll be better. That's not what I wanted. I made it worse. Get rid of you. Okay, so I'm going to create a new query window. It's hard, huge, isn't it? That's why I can't get anything to work. I don't know why it's so huge. Okay. It might make it a little bit more show up. All right, so in this left outer join, we've got a select statement, and we're starting out. I'm hearing some feedback or something. Is anybody hearing that? Could you, somebody got their audio on or something on the Zoom session?
That's annoying. Mine, I'm not sure if that costs feedback.
Well, these computers don't have mics, so you can't do that.
Yeah, it's got to be laptop. I don't think you guys can do it on the desktops unless you add in a mic. Okay, so we're gonna get our 3 fields here. And we have our vendor name, invoice number, and invoice total. I'm gonna start this query
Can you make it small?
from the vendors table. Sure.
Yeah, a little.
Try to make it right, and it's just, we
Yeah,
might,
it's just like.
we'll get it, we'll get it.
Barely too big.
And then it'll rearrange it all, it'll all be messed up again, but we'll try. Okay, so from our vendors, and then we want to do a left join on invoices.
Or just maybe like, enter anytime it goes off the screen for it to get behind.
Now, our on clause, whoops, fingers moved, on vendors.vendor ID equal invoices.vendor ID. And then I want to order by vendor name.
So why do you, like, indent the on but not the order by? Is it because the order by is tied to the select statement? Or is it on?
I was doing it like they did in the presentation, and they are super inconsistent in our textbook about it. So you guys kind of come up with your own methodology of how you like doing it. And I think that sometimes when we do our code, in this case, we want to emphasize the left and the right table. So that's why they put those table names in the left join all on one line, so that we can emphasize that. Because if we split it right there at that word left, then it's not as obvious that they're the left and the right table. Kind of, it's like, what? Okay, so run that. What are we going to get out of this query? A bunch of nulls. So what are those nulls? Because, yeah, we got our vendor stuff. What are all these nulls? So what are those kind of rows? What does that tell us about American Booksellers Association? Have we ever? Yeah, we've never had an invoice from them. So let's change this and take out that word left. How does that change our results? Remember this left join, we're saying we want all the rows from this left table, the vendors table, and then rows from the right table that can join. If we take out that keyword left, we're back to an inner join. Click the wrong thing. And we're only going to see the rows of vendors that have invoices, right? Because we're seeing only those ones that match together on a regular inner join. So if we make it a left join again, we'll see all of those nulls. So you see the difference in the data that you're going to get back? We can control whether we see all of the vendors or only the vendors that have invoices through that join. So if we do an inner join, we're only going to see the ones that have invoices. Now, sometimes people get confused with this join syntax. What happens if I'm going to find it. Where is it? There's a laptop that's feedbacking really bad. Got it? I guess I could shut off audio. In the
Surprised
Zoom
you started
session.
hearing all of us, I guess.
No, I think it's just that it's up here. Can you hear it? Giving Alex a headache, probably. It is me. Will turn it off. Okay, everybody's muted. That should be better. It's still here. All right, so that's the difference. So sometimes people get confused about these join columns. We saw the really awesome video where he reminded you we have to have a foreign key with a matching primary key to be able to establish a join relationship. So what if I did a really wrong thing and I changed this to on vendors.vendor ID equal invoices.invoice ID. I see people do this often because they're like, well, that's what invoices key, right? So isn't that what I use? Those don't match. We're not going to get any equal results. So let's run that. What do we end up with?
What is it like actually giving you though? Is it giving you things with vendor ID matches invoice ID, or is it just trying its best to give you something?
Since we're doing a left join, we're just getting something. Change it to just do an inner join, and let's see. So we can see that our invalid results can actually change based on the type of join we're doing too. It's pretty much the same thing.
But I'm curious, is it giving us everything where the vendor ID is equal to the invoice ID?
It's basically giving us a row for every invoice vendor combination. So like we're getting a complete table dump of both sides. So we should be seeing a lot of irrelevant data. So we have to be really careful because these results look good, right? It looks like it's something that's meaningful. So unless we actually look at our data and analyze and make sure that our results are valid, we can come up with invalid results. So we always want those join columns to match.
Those two IDs could be different as well. So
Yes.
I had it show the vendor ID, invoice ID, and it's showing the ones that are.
Is it matching them up pretty good? So it's figuring something out from the relationships that are defined in the database. It is going to try to use that information too. So when we create the databases and create all those tables, we said there is this relationship between these two tables. So sometimes the database management system can kind of override our ignorance and give us the right data back. But we want to make sure that we are specifying the right relationship. Okay, so left outer join. We'll get everything from the left table and information from the right table that matches. That's what a left outer join is. So in this example, they've got 3 tables. They've got a departments table, an employees table, and a projects table. For any project, it has an associated employee. So this table right here, notice that I can have the same project ID multiple times because multiple people could be assigned to it. But my employee ID has to be unique and my department number has to be unique. So those are a little bit about our tables. So if we did a left join, starting at the department, notice how we would see all of the different departments listed and we would see them repeat for every time there was an instance in the employees table. So we're going to see some duplication And then with our right outer join, we're kind of going the opposite direction. Let's look at that picture. So we saw a left join gets all of the data from the left table and data from the right table that matches. A right join is the opposite. It gets all the rows from the rightmost table listed in our join clause and gets data from the left table that matches. So let's change this query. What if we make it a right join? Bless you. So notice we don't see any of those null vendors. We only see invoices. And so for every invoice in our invoice table, we're seeing the associated vendor, because the invoice table is really controlling that join. As you experiment with the different joins, you'll see that you have a lot of control and a lot of power. Now, a full outer join is used sometimes when we want to know about all of the data, no matter what. So in this full outer join, we're going to see all of the rows from the left side table matched up to all of the rows on the right side table. So right here in this example, we have some null departments. That's because this employee, Watson and Locarno, haven't been assigned department yet. And so they show up null. So this kind of query can show us problems in the database, right? Where somebody didn't assign them to a department number properly. So if we see null on this left side, there was no occurrence in that table. We see null on the right side, there was no occurrence on the right-hand table in a full outer join. Now to specify that, we use the keyword full join. So let's try that. So now we're going to see every vendor from our vendor table with every invoice from our invoice table. Do we have any invoices that don't have vendors? We shouldn't. Look, we do a lot with FedEx, don't we? We shouldn't, because that would be a problem in our database. If we had an invoice that didn't have a vendor, we wouldn't know who to pay that bill to. So we want to make sure that we've got that. Now, in the presentation, they show you some further examples, joining 3 tables, using left outer joins. Be sure to look at all these examples as you go through the homework questions and try different things so you get a good feel for what's going on with stuff. Now, in, let's see, page 29, they show you using 3 tables using full outer joins. And in this case, we get all the rows from all 3 tables with all of the data matched up on our join keys. We can combine the types of joins that we use. So in this example, we're joining our employees to their department, but then we're going to do a left join on the projects too. So we don't have those tables to try that query, but we can see that how it would work and try some things. So a cross join it's kind of like we're just doing that implicit syntax again, because we're specifying multiple tables in our from clause and letting the database management system take care of that. I just wanted to look through these last few slides quickly. Page 36, they talk about a union operation. I think that you'll have to do a little bit of unioning. A union operation is really, really powerful. Let's do this query. Now, before we do this query, I want to save the one we were working on. So I'm going to right click on the tab and choose Save SQL Query. It's not putting it in my project. We'll call this a right join. If I look at my Solution Explorer, I'm gonna put that in my project queries. I don't know what that's doing, but I'm gonna try it. See if I can get this stuff organized. All right, so I want a new query for this union. We're gonna do a union operation, and a union operation combines data from 2 or more tables. And actually, it's 2 different select outputs. So sometimes we can't get a select statement to work properly with the data that we have. So we can union or join the results of the different select statements. So our first select statement, we're going to choose to select this word active. Make this a little bit wider. I think we've got to build some sort of tables here or something first. I'm getting errors. How about you? I don't think that they showed us that. Well, sometimes our book is just failing us here. We don't actually have these tables, but I'll go ahead and create this statement so we can save it. We're just going to change this up a little bit and use this next one. Select active as source, invoice number, invoice date, invoice total from, okay, I'm going to change our from clause and select from our invoices table that we should have. And then in our where clause, we're going to make sure we're getting these active ones where invoice total minus payment total minus credit total is greater than 0. So those are our active invoices because we still owe money on them. And then I'm going to use the union keyword. Now, in our textbook, they actually have this indent or the select statement indented. So I will do that. Now, finally, my order by clause is going to affect both result sets. Bless you. So in this example, we're selecting from our invoice table, and our active invoices are the ones where our balance is greater than 0. And then we're selecting our paid invoices, which are the ones that we don't owe anything on yet. Our union is putting them together. Now, what's happening here with these 3 words, where we have active as source and then paid as source? We haven't seen anything like that before. What's that going to do? Let's run it and see. Actually going to insert that column, that source column in our result set. So now all of the invoices that came from this select statement say active, here's their source. And all of the ones that came from this select statement say paid. Other than that, because we use the union, they're all merged together. And we see the result set as one set. Now I want to save that query as an example union.
You scroll down a little bit so I can see your
Sure.
like, data.
Can you see it?
Thank you. I
Sure.
just didn't know what less than or equal to.
You got it. All right. So page 39, the example does a little bit more work. In this example, we create some columns, like how much the payment they've made has been. We do some calculations to create additional columns. So just a little bit more involvement for you with the union statement. So a few more examples. Now, at the very end on slide 41, we bring up some keywords that can kind of change things. So when we're doing select statements, we can use keywords except and intersect. This is kind of a subquery. We should be able to do this one. Let's open a new query. For this query, I'm gonna tab in, and we're gonna use a select statement. And we're just gonna get our customer's name. What is their name column? That doesn't look right. Let's try that. Look at my customers table at my columns. First name and last name. Bless you.
Can't wait to see season.
It's already starting. A 120 class has a bunch of sick people, so probably bring germs for you guys. Okay, so what's this accept clause going to do? It's a subquery. So we'll be talking about those a lot more in a couple of chapters, but basically we're going to use this lower select statement first. So this query is going to run. We're going to select first name and last name from employees. And we're going to order by customer last. Let's try administrators instead of employees because we have that table. And we may not have any overlap. Yeah, that will work much better.
So the order by works for all of it still, right?
All of it, yes. So what we're saying is select first name and last name from our administrators table. Then select first name and last name from all of the customers table. If any customers have the same first name and last name as the administrators, they will be dropped from our result set because we don't want those. We said we want all of the customers except the ones that show up in this administrators table too. Now I'm going to run that, and we may not have any overlap between those two tables. Now what we could do to validate that is we could select first name, last name. From our administrators table. I'm just going to run this one query. And we have the Murocs. And then I could do customers and see if the Murocs appear there. That's ugly. I should order that, huh? Now I can see more. So I'll run it again and see if I can find the Murocs in there. So they're not in the result set from my accept query. Let me see if they're in my result set from my select all query. Nope, so it's a bad example. We just don't have that employees table. Well, I'll find it, we'll get it. So I think you get the idea of the accept. Now what about the intersect? Let's take a look at this syntax here. We would say select from this table and intersect it with this table. That would be the same result as a union. So as long as we have like rows, we'll just combine that result set all together. So an intersect is two different tables, but we're going to union their results together as though they were the same tables. All right, lab time. I think that's enough queries. Save that one if you can. That one was an accept query.
These names are hilarious.
I'm going to move all these into my project. So for your lab time, you probably want to focus on your assignment for this chapter with your group. And you guys can rearrange to sit with your groups and get all that done. You have quite a bit of time, so it'll be worth it.
You can make an output first, so it's kind of like, pseudocode. Remember how we did pseudocode, like Python? An output from a-
I mean, on this one,
Way too I thought you were assuming mine.
Do you know where to go?
Yeah.
Yes, move with your groups, please. Next we go to work with your tables at your like. Group 6. Group 1. Group 4. Group 2. Not yet. We will. You are with. Should be organized. Now you're with this group right here. There we go. You know.
Yeah,
And only to those customer ID and order ID. Well, I guess there's few. Those definitely use those.
Have fun.
Yeah.
I hope everything's good.
Oh yeah, they we're sharing my sorry. And they're just
Yeah, you can
so they're just trying to make sure it's
Uh-huh.
This feels more like during the week.
Oh,
So
great. Well, good luck. Just tell your team. I'm sure you did.
yeah, I'm already talking. Tuesday.
Wait, it's not. Where do you get